Number 67. We have 2x equals y minus 3 and y plus 4x equals 15. So what I'm going to do is isolate the y on this one and that one, so it's easy to see the slopes and we can go from there. Alright, so I'm going to transpose the negative 3 to this side, so I'll have 2x plus 3 equals y, or y equals 2x plus 3. Okay, and on this one I'm going to subtract 4x from both sides, so y equals negative 4x plus 15. So we'll note that the slopes are different, so they're not parallel lines, so we're expecting a point of intersection. Alright, so what I'm going to do now is let this equal that, the right side of each equation equal each other. Alright, so and then we'll solve for x. 2x plus 3 equals negative 4x plus 15. Then I'm going to add 4x to both sides, or transpose the negative 4x to that side, and you get 2x plus 3 plus 4x equals 15. And then subtract 3 from both sides, so you get 2x plus 4x, which I'll just simplify to 6x, equals 15 minus 3, which is 12. And then divide both sides by 6. The 6's cancel on the left, so you get x equals 2. Alright? So now all we need to do is figure out what y equals. So you can let x equal 2 in either one of these equations. Alright? Use the easier one, the one that's easier for you. Let x equal 2 right there. Substitute, and that'll give you what y equals. So y equals 2 times 2 plus 3, which is 4 plus 3, or 7. So we have the point of intersection 2, 7. Alright? Number 69. We've got 5x plus 3y equals negative 65, and x minus y equals negative 5. Alright, so I'm going to isolate the y on this one and then substitute the expression involving y into here. Alright, so y on this side will equal x plus 5. Okay, so you're going to have, move that over to the right, that becomes y. Move the negative 5 over to here, that becomes positive 5. Equals y. So y equals this, so you're going to plug that in right there for y. So you got 5x plus 3 times x plus 5 equals negative 65. Alright. So we've got 5x plus 3x plus 15, distributing the 3 through, equals negative 65. So 5x plus 3x is 8x. Subtract 16, or 15 rather, from both sides, so you're going to get negative 65 minus 15. Alright? And so you've got 8x equals negative 80. And then you divide both sides by 8, so you've got 8x over 8 equals negative 80 over 8. Cancel the 8's on the left side, so you get x equals negative 10. Alright? So now we can use this y equals x plus 5 to calculate what y equals. So y equals negative 10 plus 5. Again, I'm using this equation. Let x equal negative 10. And so you're going to get negative 5. So the point of intersection is negative 10, negative 5. All right. Number 71. Find the equation of the line perpendicular to the line g of x equals negative 0.01x plus 2.01 through the point 1, 2. All right. So the slope of the perpendicular, well, let me write g of x here first. G of x is negative 0.01x plus 2.01. And it's through the point 1, 2. So the slope is negative 1/100ths on the original line. So slope of g of x is negative 1/100th. Alright, so the slope of the perpendicular line will be the negative reciprocal of that. So the reciprocal of this is negative 100 over 1, or negative 100, and the negative of that is 100. So slope of perpendicular is 100. All right. So we also have the point that we need, 1, 2. Call that x1, y1. All right. So we'll use the point slope equation. We have a slope, we have a point, so we use point slope equation for a line. Y minus y1 equals m times x minus x1. So we've got y minus 2 equals 100 times x minus 1, or distributing that, 100x minus 100. Add 2 to both sides. So you get 100, y equals 100x minus a 98. And there we go. Number 73. Let f of x equal negative 0.1x plus 200 and g of x equal 20x plus 0.1. Where is f of x greater than g of x? Well, one has a negative slope, one has a positive slope, so you're expecting some kind of an X shape going on here, like this. This one would be the negative slope line. That would be f of x. And the other one would be g of x with a positive slope. And so you expect f of x to be greater than g of x to the left of their point of intersection, right there. To the left, f of x is above g of x. In other words, the y values in f of x are greater than the y values in g of x to the left of the point of intersection. All right? But we can also do this algebraically. Let's do that. I'm going to write f of x greater than g of x. And so f of x is negative 0.1 x plus 200. And greater than 20x plus 0.1. And so we've got negative 0.1x, and I'm going to move this 20x, transpose it to the left side, so you get minus 20x. And then transpose the 200 to the right side, make that a negative 200. So that's greater than 0.1 minus 200. So simplifying, I get negative 20.1x is greater than negative 199.9. Now what I do is divide both sides by negative 20.1. Remember to change the direction of the inequality. Whenever you multiply or divide both sides of an inequality by negative number, you have to change the direction of the inequality. For example, suppose I write 7 is greater than 4. Alright, that's true. What if I multiply both sides by negative 1? I get negative 7 on the left and negative 4 on the right. Now which one is greater? The negative 4 is greater. Alright. Notice the direction of the inequality has changed. Same thing applies if you divide both sides by a negative number. Alright. So you do that. Remember, that also applies to greater than or equal to or less than or equal to. You change greater than or equal to less than or equal to, or vice versa, if you multiply or divide both sides by a negative number. Okay, so divide both sides by negative 20.1. All right, and so you're going to get x on this side, and then change the direction of the inequality. Is less than 190 negative, or rather positive now. Negative divided by negative is positive. So you get 199.9 divided by 20.1. And now let's look at this number. We can write this without the decimals. We've got 199. I'll just do it over here, over in this scratch area here. Alright, 199.9 over 20.1 is equal to 199.9 over 20.1 times 10 over 10, correct? All I'm doing is multiplying by 1, so yeah, they're still equal. But 10 times 199.9 is 1999. And 10 times 20.1 is 20, not 20. 10 times 20.1 is 201. All right. Okay. So I can write x is less than 1999 over 201, 201. Okay, so where is f of x greater than g of x when x is less than this number? Okay, that is the x-coordinate of their point of intersection. If that, you think of that as the x-axis there, that's 1999 over 201. Alright, so f of x is greater than g of x to the left of that, or when x is less than that. Alright, this is number 73, bonus proof. Bonus proof. Yeah, don't be scared. You will be able to understand this, and you'll probably learn a little bit more mathematics just by going through this proof with me. And let's take a look at what we're going to prove. The problem 73, we showed where those two lines intersected, you had one going like that and the other going like that in an X shape, and the point of intersection happened to be on the right of the y-axis. And you might wonder, well, is that provable? Can we prove that that's always going to happen with those conditions? And well, yeah, the answer is if we have these conditions satisfied that I've written up here, it is provable, and I'll show you the proof in a second. But let's go over the statement of this. So suppose f of x is m1x plus b1. In other words, f of x is written in slope-intercept form, and its slope is m1. We're going to call it m1, and its y-intercept is b1. And then we have g of x, which is m2x plus b2. So the slope of g of x is m2, and the y-intercept is b2. Okay, so those are just equations of lines in slope-intercept form. That's all. And we're going to put the conditions like m1 has to be less than m2. All right, m1 is less than m2, and the in other words, the slope of f of x will be less than the slope of g of x. All right, and the y-intercept of f of x, b1, is greater than b2. All right, so in other words, on the y-axis, b1 lies above b2. All right. Suppose also that f of x and g of x intersect at this point x1, y1. All right, what's x1, y1? Well, it's just wherever they intersect. We'll assume that that's where those two lines intersect. All right. Well, if that's all these conditions are satisfied, then x1 must be greater than 0. x1 is the first coordinate of the point of intersection. x1 must be positive, in other words. All right. So we're going to prove this. So I will write proof. All right, so there are 2 points on f of x. There are 2 points. These 2 points lie on f of x. Viz, V-I-Z, that's short for videlicet, which is Latin for namely. So there are 2 points of on f of x, namely, or viz, 0, b1, and x1, y1. Does that make sense? 0, b1 is the y-intercept of f of x. All right. That's when x equals 0, so it's on the y-axis, and b1 is where it actually touches the y-axis. So that should make perfect sense. And also x1, y1 is on f of x because f of x and g of x intersect at that point, so that point has to be on f of x as well as on g of x, all right? So that was just the condition that we made. So we can use that condition. Now there are also 2 points on g of x. And you can see where this is going maybe. It's similar. There are also viz, or namely, 0, b2, and x1, y1. Now there are other points on these two lines, but we want to call attention to those two in particular because they are on those two lines. All right. So what can we do now? Then we have M1 is less than M2. Where does that come from? Well, that was one of the conditions. All right. The slope of f of x is less than the slope of g of x. So we're just using the condition that we gave. All right. Well, what is M1, or how can we describe M1, the slope on f of x? Well, we've got these 2 points that we know are on f of x. All right. So we can use the formula for slope with 2 points on that line. And write that down. Instead of M1, you write y1 minus b1 over x1 minus 0. Is that? I'm using the formula y2 minus y1 over x2 minus x1, right? And this is the point x1, y1. And that's the point x2, y2, except you got all these little subscripts running amok. So you have to sort those out in your brain, all right? The formula for slope is stated in a general form, y2 minus y1 over x2 minus x1. So you just have to kind of substitute into the formula using these 2 points that we have written down, all right? So that's the slope M1. And we're saying that's less than the slope on M2, which we can write using these 2 points. All right, so that's y1 minus b2 over x1 minus 0. All right. So we know so far everything is true. All right, that's how we proceed in these proofs. Everything has to work, everything has to be true. Alright, so let's simplify it a little bit. y1 minus b1 over x1 is less than y1 minus b2 over x1. Alright. Alright, now what I'm going to do is I'm going to subtract y1 minus b1 over x1 from both sides of this inequality. Alright, so in other words, you can transpose this to the other side, make it a minus, put a minus in front of it, move it over here, and you've got, what do you got left there? You got a 0. Alright, so I'm going to write starting here and then going minus that is greater than 0. So we've got y1 minus b2 over x1 minus y1 minus b1 over x1 is greater than 0. Alright, so again, subtract this from both sides of the inequality. Alright. Now, how nice, they both have the same denominator. They have a common denominator. So all we have to do is subtract the numerators. Alright. So what do we have? We've got y1 minus b2 minus y1 plus b1. Right? So again, you're subtracting the whole numerator here. So you put a minus and then parentheses around it, and then that becomes minus a y1, and minus a minus is plus a b1. Alright, that's where that comes from. All over x1 is greater than 0. Okay? So I'm running out of space. Let me move it up here. Alright, we'll continue there. Now you just simplify the numerator. You get b1 minus b2 over x1 is greater than 0. Alright? Now, what we have is a fraction which is positive, in other words. A fraction which is positive. This fraction is greater than 0, which means it's positive. Alright? Now, that means that either both the numerator and denominator are both positive, or the numerator and denominator are negative, right? Because negative over negative is positive. Alright, well, is that second case true? In other words, are these both negative? Well, if so, then this x1 is going to be negative, which means less than 0. That's not what we wanted to show, right? Our proof would fall apart at that point. However, what about b1 and b2? We already said that b1 is greater than b2. b1 is greater than b2, and so that implies that b1 minus b2, b1 minus b2 is positive or greater than 0. Subtract b2 from both sides. All right. That means this numerator is positive. Well, if you have positive over negative, that's not going to be greater than 0. All right? But we already know this is true because it follows using the laws of algebra and mathematics. All right? From everything else which was true before it. Okay, so this is true. Therefore, x1, I'll put the symbol for therefore, 3 dots in a triangular pattern. Therefore, x1 is greater than 0. Alright? And now I can write QED which signals the end of the proof. Alright, so since the numerator is positive, definitely, the denominator must also be positive in order for this whole fraction to be positive. Alright, so that's exactly what we wanted to show. We wanted to show that the first coordinate of the point of intersection is to the right of the y-axis. In other words, the x1 has to be a positive number. Alright, it has to be greater than 0. So, and QED is short for the Latin phrase quod erat demonstrandum, which means which was to be shown. So traditionally that's what you would write in mathematics at the end of a proof. Nowadays they use little square boxes to signal the end. They don't seem to use QED too much anymore. I think you know, back when students had to take Latin in high school, a lot of high schools offered Latin, including the one I went to. I never did take Latin though, so I'm catching up. I'm playing catch up. All right, so yeah, I picked that up along the way of getting my degree in math. So I like the older traditional ways anyway. I'm kind of an old school guy. All right. So yeah, QED. So that proves it. Okay. And you can prove something similar for the other case. What about when the point of intersection is to the left of the y-axis? All right, when the conditions change a little bit, you can also prove that case doing something similar to this, or maybe you can come up with another way to prove it. All right, but there you go. I hope that was an enjoyable experience. If you enjoyed it, if you kind of like that, the logic involved and the mathematical reasoning involved, you may have the makings of a mathematician. You may be a math major and you may not know it. All right? So maybe if you didn't like this at all, well, you can still learn from it. Okay, so anytime you come across a proof in a math book, don't give it short shrift. Read it through and understand. Read it with understanding, and then you've learned something. And you've also demonstrated to yourself that you've learned something by understanding it. Okay, and you may learn something new. So that's it for our bonus proof. And hey, we've got the last exercise, 75. A cell phone company offers 2 plans for minutes. Plan A, $20 per month and $1 for every 100 texts. Plan B, $50 per month with free unlimited texts. How many texts would you need to send per month for Plan B to save you money? Okay, well, $1 for every 100 is the same as 1/100th of $1 per text. $1 for every 100 texts. $1 for every 100 texts is the same as 1/100th of $1 per text. In other words, 1 cent, 1 penny, all right, per text. You have 100 texts, is $1. So each text costs you 1/100th of $1, or 1 penny, 1 cent. All right. So we're going to let T equal number of texts per month. Okay, by the way, NO dot means number, in case you're not familiar with that. I don't see that too often anymore. A lot of people use this as number nowadays. In mathematics, we use that to indicate a contradiction. So I use the old NO dot. If you don't just put NO, because that means no, but put NO dot, that means, well, that comes from the Latin word numero, which means by the numbers. All right, so this means number of texts per month. MO dot is month, of course. Okay, then let's see. Let's call Plan A is A of t, and Plan B is B of t. That's easy to remember. Okay, so A of t, what was Plan A again? It was $20 a month and $1 for every 100 texts. Okay, so that's 1/100th times t plus 20. The $20 a month. That's the constant charge every month. And then you put the number of texts you do here. Like if you have 100 texts, 100 times 1/100th equals 1. So it's going to cost you $1 plus $20 that month, or $21. Okay. And now B of t is always, Plan B is $50 a month. Free texts. So B of t is just 50. Constant rate every month. So where or how many texts would you need to send per month for Plan B to save you money? In other words, where is B of t less than A of t? That's what we want to answer. b of t, set b of t less than a of t, and then solve this. Alright? So we've got 50 less than 1/100th t plus 20. Okay? So subtract 20 from both sides, you got 30 is less than 1/100th t. Multiply both sides by 100, that gives you 100 times 30 is 3,000. And since we multiply both sides by a positive number, you don't have to change the direction of the inequality. So you got 100 times 1/100th is 1, so that's just t. So that's when t is greater than, you could read it from this side, t is greater than 3,000 texts per month. Plan B will save you money over Plan A, but only if you send more than 3,000 texts per month. All right. Well, that takes care of section 2.2, graphs of linear functions. All right, and so it's been real, folks. It's been real. All right, we'll have to do this again sometime, won't we? In fact, I plan on doing 2.3 next, and I'll hope to see you then. All right, so have a good rest of your day or night or whatever it is, and pat yourself on the back for a job well done. So take care. See you later.